In this video, we are going to go over three-way handshake process in TCP. We have already discussed the transport layer and its protocols, TCP and UDP. The UDP is usually used in applications such as video streaming, where large files are transferred over the network, and thus transmission speed is the most important factor. However, in applications such as web browsing and email, communication reliability has the highest priority, because if data packets get lost, duplicated, or manipulated during transmission on the web, it may cause serious damages. For example, if an account holder decides to withdraw $200 from his or her bank account through the web, and this request arrives at the server as $2,000 because of the unreliability of communication, that could cause a serious problem. So because of these types of concerns, applications such as web, email, and file transfer are classified as error sensitive, and they have to use TCP. To ensure reliability, TCP has to create a connection between client and server before data exchange, and then terminate the connection at the end of data transfer. The connection establishment process in TCP is called three-way handshake, where the client and server get into an agreement to start data exchange. Through three-way handshake, a virtual path is going to be created between the client and server, and all segments belonging to a message are going to be sent over this path. In unreliable communications, UDP goes through the data exchange phase without creating or terminating a connection for data exchange. In three-way handshake between a client and a server, the server listens to the incoming requests through its open ports. In other words, the server tells its TCP that it is ready to accept a connection. This step is called passive open. After that, the client sends a request for an active open. In this step, the client tells its TCP that it needs to be connected to a particular server. Here in this picture, we see the segments with their associated fields set for a three-way handshake. The three steps include: first, the client sends a segment for an active open request. In this segment, the TCP of the client sets the SYN flag. When the client sends its segments with a sequence number of 1000, the sequence number is going to be incremented by 1. The sequence number is a 32-bit field in the header of TCP to trace a segment of a message and see whether they have been delivered or not. It is assigned to the first byte of data in a segment, and each party has its own sequence number. In the second step, the server accepts the request by setting the SYN and ACK flags. This segment, in fact, acknowledges the receipt of the first segment from the client by incrementing the sequence number by 1. So the segment with the sequence number of 1001 is going to be sent to the client. In the third step, the client acknowledges the receipt of the second segment by setting the ACK flag. The three-way handshake has a big security problem called SYN flooding attack. In this attack, hackers send out millions of SYN requests to the server. For each connection, the server must allocate some resources such as a communication table and timer. If the number of SYN requests is large, the server will run out of resources and it will eventually crash. This type of attack is called DOS, denial of service, in which hackers try to take a server down by sending fake requests rather than stealing information. These kind of attacks are usually detected by intrusion detection systems. The IDS checks the request patterns, and if determined safe, it will allow clients to connect with servers. After connection establishment, the client and server exchange information, and once they are done, the connection must be released. Either of the two parties involved in the data exchange can initiate connection termination. Again, a three-way handshake is performed between the client and server to close the connection. In the first step, the client sends a segment with its FIN flag set. The server TCP sends back a segment with its FIN and ACK flags set to confirm the receipt of the FIN segment. In the third step, the client TCP sends a segment with its ACK flag set. Upon receiving the third segment by the server, the connection is released.